All right, guys, so there's a question right now. It's page 506, 2425. Sort of see that. This. Yeah, okay. Alright. So 24 says if the sample is truly representative, so this is a histogram of a sample they took of starting salaries of recent college graduates. Right, so, of course, that picture's gotten worse over the last several years, but oh well. It's starting to come back a little bit. It says, if this sample is truly representative, then for a group of 400 college graduates, we can expect about 28 of them to have starting salaries in the $31,000 to $35,000 range. Okay, so, that, I love this question. How many total people were in this sample? About how many? So how could you figure that out? How many total people were in this sample? How many total people from the sample had $31,000 to $35,000 starting salary? 70. Yeah, I'd say roughly 70. Okay, cool. So write that number down. So 70 so far. To answer this question, you have to know the total number of college graduates that are actually in this sample. So go with me for a minute. How about for the next bar, about how many? 140 or so? Okay, so we got 70, 140, so far 210. This one? 320, okay, I like it. So 320. So far 530, is that right? So we got 70, 140, and 320. Let me stop here for a second. Everybody aware of what these numbers mean right now? You're a math man, it's just numbers. No, I mean, what do the numbers mean? They're the amount in each bar. I want to figure out the total amount of people that they talk to. It's a good number to know, because then I can figure out percentages of stuff, right? Where am I at? This guy.
275.
I like it, so right in the middle. So 275. Here, I'd say 125, right? So right in the middle again, 125. And then where am I at? Here, 50, and here, maybe 20. I'd say it's a little bit less than halfway, right? Let me see. You said 50 and 20, so another 50 and 20. So how many total is that? 30, 1,000, I think. Which is a nice round number. I like that. Can somebody check me out? You never know. It's early in the morning. I don't know if my math is strong yet. Didn't do my math stretches. All right, so now that I know there's 1,000 people, I'm going to just take that to be true. I'm going to assume somebody actually checked me on that. We know there's 1,000 people in this survey. The question is, if the sample is truly representative, then if we had a group of 400 college students, so we got 1,000 students, from this 1,000, how many had $31,000 to $35,000 salary, starting salary? How many had a $31,000 to $35,000? 70. So 70 out of 1,000. Let me stop there for a second. Now they're asking, what if we had 400 instead of 1,000? Does anybody know an equation I could set up for this? There's 70 that have a starting salary of $31,000 to $35,000 out of 1,000 graduates. What if it was out of 400? How many would you expect? Can I set up an equation, or can I use Percentages. What percentage is this? Isn't it 7 out of 100? So what percentage is that? What's percent mean?
100.
Per 100. So 7 out of 100 is what percent? 7%. Yes. Okay. They actually don't have to go that far. If it's 7 for every 100, how many would I expect for 400? 7 for every 100. And now I'm asking how many out of 400. That's the question. That's what number 24 says. How many out of 400 would you expect?
7% times 400
Or just, you multiply by what? You multiply by what? To go from 100 to 400? Times 4. So then you got to do the same thing to the top. Yeah. So it's true. You would expect 28 out of 400. If this is truly representative, then each one of these bars should represent the percentage out of whatever. So if I have a different group of people, a larger group of people, a smaller, I can then still use the percentages here to estimate how many I would expect. So if I took a group of Grossmont students and randomly selected them, a group of 100, and I found 11 of them are left-handed, how many would I expect out of 300 to be left-handed? 33, right? If there's 11 out of 100, there's 33 out of 300. Is everybody cool with that idea? That's just building a fraction. That's the opposite of reducing a fraction, building it up. Right? 11 over 100, that fraction represents the number of left-handed people out of my sample. If it's a good sample, then I can assume that it works for larger and larger or smaller groups. That ratio should hold. If it's a bad sample, if it took you guys, and again, you're not bad people, you would just be a bad sample, right? We talked about that before. Then I couldn't use what I find, because you're not representative. You're not a good sample of Grossmont students.
It's not you, it's the sample.
Sure, exactly. I think George Costanza came up with that. Okay. So that's number 24. Number 25 says the percentage of starting salaries falling above those shown by any rectangular bar is equal to the percentage of starting salaries falling below that bar. That's just a weird ass question. So I don't blame you for having. This is both a poorly worded question and kind of a silly question. It doesn't make sense. So what they're saying is for any given bar, the percentage above it is the same as the percentage below it. Well, that's an easy one to answer once you understand that's what they're asking. Pick a bar. Is the percentage above it the same as the percentage below it? No. The percentage above this bar is way lower than the percentage below it, so that's false. That question is just admittedly kind of silly. Okay. This is page 506. Number 24 and 25. Yes.
Number 34?
Oh, in the same section?
Yeah.
Okay, so this is a very... This one here?
Yeah.
Okay. Alright, so if you read through this section, they give you ideas about how to make a bad graph. And the reason they do this is to keep you away from that and to notice when people make a bad graph. So one thing is to have the scale be not right. So the scale could be off, so it makes things seem like they're way more out of whack than they really are. Something else is to use three-dimensional objects to capture a one-dimensional idea. So in this case, the total book output is being represented by these three-dimensional books. So that's immediately misleading. I mean, it makes it look like, this book is bigger than the other books. It is more, but is it really that much more than the other ones? Not necessarily. They should have just made a normal bar graph for this. There's no need to bring in these visual images. So sometimes they'll use a dollar sign, and they'll have this giant dollar sign that's like way bigger, and you're trying to overstate the differences between things. So one big thing they talked about in this section was using images that are three-dimensional or even two-dimensional to illustrate something. Here we go. So right here, they talk about when you look at area, it overstates the differences. Right, so when you use a two-dimensional object, the area grows much quicker. So think about it. If I have a square, and the area is 4. So if I had a square, the area is 4. How big is each side? If the area is 4, each side is 2. Is that cool? Now what happens if you double the side? What happens to the area? Make the sides double. Now how big is your square? 4 by 4, right? 16. So if I double a side, does the area double?
Yes.
What's 4 times 2? Okay, if I double the sides, did the area double? If it doubled, then what should it have been? 8. Is it 8? No. So what did the area do? It multiplied by 4. So when you have a 2D, or even worse, a three-dimensional object, oh shit. So if I had a cube, and it was 2, 2, 2, what would the volume be? 8. I love it. Now if I double a side, now it's 4, 4, 4. What's the volume now?
64.
Oh my God. So here I double a side, the area squares. I double the side of a cube, the area squares again. It multiplies by 8 in this case, right? It's 8 times larger, not twice as large. So that's why it's no good using images to represent differences in things that are not three-dimensional. Money's not three-dimensional. Money is a 1D idea. $4 or $5 is just kind of follow what's happening here. So that's one reason why using images is misleading. They're trying to overstate something. Yeah, and the public doesn't even know to look out for that. But now you guys should, because hopefully you actually read the section. So they give you a beautiful example, and they explain what's wrong, the length and width. So the whole thing we're talking about up here, the area increases more than it should, more than what they're trying to represent. Okay, so hopefully as you do your homework, my God, guys, my God, if you were a math major, you get to a point in math where the book is this skinny. It still costs $100-something stupid dollars, right? You open it and you flip, 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 and there's problems. And you're like, wait, there were no examples. There were no examples anywhere. There's no examples anywhere. It's all just concept, concept, concept. So my God, you better appreciate that you have examples to go back to. And if you're not doing that, I don't understand you. You should be reading the book. But at the very least, you should be going back to see examples to see what's going on. Is that cool? I mean, you have to. And if you're wondering why you're not doing as well as you want to be, that's one thing you can control. Right? Okay. Any other questions from homework that I can use as a way to admonish you further? Or just answer it. We'll see. Alright, so remember last time we did some of chapter 2, so that was just a preview. That was my mistake. We're going to go back to 7, which is what should be next. Yes?
Chapter 8.2, number 42 and 54.
So the thing you've got to be careful about, what is it that you have to be careful about when you're doing like median? I know this one says 42 says mid-range, but let's just do this one. I want to make sure you get the right idea. 42 gives you these numbers. And it says find the mid-range. Now what was the mid-range? How do you find the mid-range?
5 plus
10
3.
plus 1 over 2.
Yeah, high plus low divided by 2. So it's the average of the highest and the lowest. That kind of makes sense because that's going to be the middle of the range. Mid-range, crazy. Now, the mistake somebody's going to make is they'll do this. I've made a mistake because I assumed something that's not going to be true. I assumed that the numbers were in order, and they're definitely not. So median requires numbers to be in order. High and low, you got to be careful not just to assume that the numbers in the front and the end are them, because it might not be in order. So what should this be? 10. That's the highest number. So if it's not in order, I'll just put it in order right away. It'll keep me straight for everything that I got to do. Mean doesn't care. So putting it in order won't mess it up. Putting it in order will make other things work better. Okay. I love you guys. I never want to play poker with most of you. Because you're all... I would need huge glasses to cover my face because I can't. I play poker like this. That's why I don't play. Yes.
It's on page 5 of 5, not this one.
You said section 8-2.
Yes.
Okay.
I'm sorry.
That's all right. That was a beautiful little...
It's on page 520.
That's the one. Yeah, 520, number 42?
No, number 49.
49.
49? Okay. I thought you said two things. Sorry. All right. All right. My big finger. Find the mean, median, mode, and mid-range, right? I kind of lost that word yet. Somebody explain to me what this means. So, for example, there's a 10 here, and the bar goes this high, and there's a 20, and the bar's higher. What does that mean? What's going on here?
The amount is growing.
Okay, beautiful. Now, be much more specific.
The data is
No. Be much. How many 10s are there in my data?
1.
One. There's one 10, so you can write a 10 down, comma. How many 20s are there?
2.
So 20, comma. How many 30s are there?
4.
So do you see what I'm doing? I'm recreating. There's 4 30s, right? Don't make assumptions. 1, 2, 3. No. 4. Make the list of data if you need to, right? And then you can just do mean, median, mode, all the stuff like you normally do. So they're just giving you the list of data in a different way. They're saying, I'm not going to write all those repeats. And you're like, I need all those frickin' repeats. So you just rewrite the list if you want to. There are other ways to do this. Since it's symmetric, where do you think the mean is? You said it, but I want you to own it.
30.
It is 30. What's the median? 30, because it's symmetric. That's going to fall right in the middle. And what's 50 plus 10?
60.
Divided by 2 is 30. What's 40 plus 20?
60.
Plus divided by 2 is 30. And then all the 30s are 30. So the average is 30. And whenever it's symmetric, the middle thing is the mean. And the middle thing is the median. What else do you ask for? Mode is stupid easy here. Please let it be nice. What's the mode? Because it's the one that occurs the most. So this was an easy question because it's symmetric. If this bar was higher, I couldn't do it as easy as I just did. I could write the list out and then work with it, sure. But since it's symmetric, this was a much easier problem. Does that make sense?
Yes.
Okay? Okay. I don't care about me. I know I'm good. I got my degree. I want you guys to be good. And then the mid-range is easy here, right? What's the highest number? 50. Lowest number is
40 divided by 2.
Careful.
20.
Careful. You average them, so you add them. 60 divided by 2.
So 30.
30. Everything's freaking 30. Almost. Right? Everything's 30.
30.
30, 30, 30, 30. Why was that problem easy? Because it was symmetric. Even if you didn't notice that, you can do like I started to. If you didn't notice the shortcut, you can still make the list of data and just attack it like normal. But if you notice the shortcut, that's great. If you don't, oh well, you know what to do still. You
So
just
all symmetrical items are just like that.
everything that's perfectly symmetric, the mean equals the median equals the mode equals the mid-range. It's crazy. And that's a big thing in statistics. I don't know if I think I've said this word. This is a normal curve, like a bell curve. So the bell curve is a hugely important thing. If you do take statistics, it's going to rule like 3/4 of your life in that class. Yes?
Same page number 54.
So this one's the same kind of thing, but you just have to. It's my thumb this time, just a. So it's the same instructions. It says find the mean, median, mode, and mid-range. Can you tell if this is symmetric or not? No.
No.
In fact, I don't think it is. It looks like it's skewed to this as long as here. So just, what's my list of data? Now they don't give us a key, so we're just going to have to assume it's the most obvious thing. That's what I don't agree with the book. They should give you a key. But so what do you think this means? 28. But it is in order. That's nice. So can't you find the median pretty easily? You can just get the middle number. The mean, you just add them up, divide by how many there are. So it's not going to be as easy as the one we just did. Because the one we just did was symmetric, so there's some shortcuts. Here, it's a list of data. They just gave it to you in a different way. So how do you find the mean? You take 28 plus 32, blah, 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 divide by how many there are. Is that cool? How many data points are there? 9. Beautiful. I love it. I hate when people count these. These are pouch the numbers, right? I like it. So you add them up, divide by 9. And then define the mode. Well, the mode kind of jumps out at you. What's the mode?
34.
Yeah, 34. That's the only one that occurs twice. It's the one that occurs the most. Mid-range, you can see the high and the low. Okay, do you guys see that? So if I give you a list of data, you should be able to do that question easy. I understand that it's a little harder when they don't give you a list, but realize that's just a list of data. That's all it is. It's just a little bit different format. So is the other one, but it had a shortcut to it. Like it. Okay. I like it. Anything else from chapter 8 stuff? Anybody gotten to 8.3 yet? Yes.
8.3, number 38.
Oh yeah, 38. Alright guys, so the first question says, just by looking at the numbers, can you tell which one is going to have a larger standard deviation? Which group of presidents? The first, what is it, 6 or the most recent 6? Which one's going to have a larger standard deviation? What does a larger standard deviation mean? The data is going to be more spread out. So which one's more spread out? Yeah, this guy, right? It's got 69, it's got 46, right? Obama was young when he got into office. That was 8 years ago, so I mean, yeah. Are you guys, okay, that was part A. Part A just says, just by sight.
Which page is this?
This is section 8.3, 530. All right. Now, everybody got that handout for the standard deviation, right? The one that actually shows you how to calculate standard deviation. Is that cool?
Was it yesterday?
I think it was the day before. Let's see. Do you need a copy? It's, I don't know if I have a blank copy. Do you have it? All right. So, the reason I bring that up is part B says calculate the standard deviation for each of these. We just predicted that the standard deviation S should be bigger for these guys. So you're going to prove that. You're going to calculate this standard deviation. You're going to calculate this. So what do you have to do very first thing before you can start standard deviation calculation? Say a little prayer to your favorite deity, whoever that is. Oh God of math, wherever thou art. First off, you suck. Secondly, can you please help me? What's the very first thing you got to calculate?
The sum.
Sure, the sum on the direct, yes, the mean. You got to calculate the mean because it's all about how far away from the mean every data point is. So the very first thing you do is calculate the mean of these. Then you find the difference between that and the mean. Then you square them, right? It's the whole process we went over, and hopefully it made some sense as to why we do those steps. But now you know the steps to take. So the number you get for this should be decently smaller than the number you get for this. Because these are much tighter. These are much tighter together. I like it. I like it. Because, back in those days, if you made it to this age, you were something good about you. I'm sorry, I don't know why I had to. But nowadays, it's like 50. Back then, I'm amazed. Adams, he was 61 when he was inaugurated. That's pretty old back then. All right. Okay, cool. Anything else from homework before we get into 7? Maybe I'll get 2, 4, 6, 8, 10, 14, 16, 18, 20, 22. All right. There's a cool thing that I like to do related to probability, but it requires somewhat of a larger class to be sure to work. If I get above about 34 people, then I know almost for certain that there will be 2 people with the exact same birthday in that classroom. And does that sound like it makes sense? Some of you guys are saying yes. You're all like, you said it must be true, and I just want you to feel good about it. Or maybe you know about the birthday paradox. Right? Must be true, you said it. All right. Yes. So if you've never heard of this, the reason that some of you guys think it's not true is because you're thinking about yourself. Nobody's got my birthday. What are you talking about? So if I have 34 people in a classroom and I say 2 of them have the same birthday, it could be any pair of them. And how many pairs of people are there, even in this classroom where we have 23 people? There's a lot. You and you, you and you, you and you, you and then I'm going to go you and you, you and you. That's a lot of pairs of people. So there's a lot of chances for 2 people to have the same birthday. So let's just see. Why not? What the hell? Everybody do me a favor. Let's just see. I can't guarantee it's going to happen for us because we're a really tiny group of people, but it might happen. I'm going to play along with you guys. Take out a blank sheet of paper. Let's see if I have a blank sheet of paper. Yes. And just write the day you were born on it. I was born September 21st. Shut up, Jim. So this is my birth week. I celebrate a birth week because I had to work yesterday. So yesterday was not really my celebration. Thank you. Thank you. Sorry. It's my birth week. You're not late. Happy birth week, Jeff. Yay. All right. So does everybody understand what they're writing down? Just the date, the day. You don't have to put year. All right? I was born in 72. You don't have to tell me. All right, put that down. Thank you, sir. I appreciate the enthusiasm. All right, let's see whether this might be true. Where are my January babies? Go ahead, January babies. Hold up your number for me. 19th and 24th. That would have been so cool if you guys would have born on the same day with us. Bam! All right, so 19th and 24th, 5 days apart. I don't know how many years apart, maybe. All right. February babies. Where are my February babies? 26th and 8th. All right. Where are my March babies? 23rd, 9th. I got like 2 per month so far. This is neat. January, February, March, April. 18th and 14th. All right. January, February, March, April, May. Anybody May? Oh, screw May. All right. January, February, March, April, May. June. You got June. All right. June, July. 20th, 1st?
Yes.
1st and 29th. All right. July, August. August? Screw August. September? 18th, 8th, 25th, 21st. Man, we got close. October 29. You got it. You own October. So we got to remember. Who else? Somebody else had someone coming up. 29. September, October, November. 5th, 29th, and 27th. Man, you guys, I was excited for a second. Where are we at in November? December. 21st, 24th, and 8th. Okay. So if I had, that was kind of anticlimactic, but like on the first day of class, when I have a stupid amount of people, and I got crashers on the wall, I got like almost 60 people in a classroom, I am almost willing to put money that 2 people will have the same birthday, and very often I get 3 or 4 pairs of people with the same birthday. There was one time I had to go to November before I got any matches at all, and I was like, oh, there's got to be, but it's not a 100% chance. So here's the secondary thing, and what I'm trying to illustrate right now is what you know as a fact. Probability is not hardwired into us. We don't understand it because it's not hardwired into us. We only know enough to keep ourselves alive. So if it's a certain time of day, you might go home a certain way because the probability you get home within a good amount of time is better if you go that way, right? We live in this area. You know what I'm talking about, right? Certain time of day, you probably don't go anywhere. I just sit there and, oh, well, shit, I missed my window of opportunity. I am here now for a while because I don't want to sit in traffic. Screw that. All right. You're even just trying to leave the freaking school sometimes. Oh, shit. All right, well, I'll just sit in my office for a while and wait for the masses to get out of the way.